Hello students, this lesson is on rationalizing with conjugates. So to begin this, we need to review a couple of things. So let's look at a couple of problems. This first one is 2 plus the square root of 7 times 1 plus 3 square root 7. Okay, so if we have this, we're going to use, you can either use the box or foil. I'm going to go ahead and use foil just to save space. So with foil, you're going to take 2 times 1, that gives you 2. And you're going to take your outside terms, 2 times 3 radical 7 would be 6 radical 7. And then on the inside, 1 radical 7. So when you add those together, that's going to give you 7 radical 7. And then the last terms, radical 7 times radical 7, would be radical 49, which is 7. So it gets rid of that radical. So then you would just collect your like terms. Well, I've got a 2 and a 7, so that would be 9 plus 7 radical 7. Okay? And then that would be your final answer. And this is just simplifying. Okay, well, let's look at another one. On this one, I'm going to have 3 plus radical 2 times 3 minus radical 2. Okay, so I'm going to do the same thing, use FOIL. So 3 times 3 is 9, and then 3 times a negative radical 2 would be negative 3 radical 2, and then 3 times positive radical 2 would be 3 radical 2. What ends up happening is that those cancel, and so I'm not going to have a middle term, and then when I do the square root of 2 times negative square root 2, it's negative square root 4, which is negative 2, and so then my answer is 7. Okay, this problem number 2 right here, 3 plus radical 2 and 3 minus radical 2, there's a special name that goes with that. Those are called conjugates. Okay, and you'll recognize a conjugate. We use it for a couple of different times. We use it with radicals, we can use it with imaginary numbers, and then when you get up to calculus and pre-calculus, we look at sine and cosine conjugates. But basically they look like a difference of squares and they have a special purpose, especially when we're simplifying radicals. The main reason why we use conjugates is because if you notice in that previous review problem, they remove all radicals. So this will be helpful. We just got done simplifying when you're dividing radicals and rationalizing the denominator. Well, we're going to use this to rationalize the denominator when you have a binomial in the denominator. Okay, so I want you to write this down. If the denominator is a binomial, then you will have to use the conjugate to rationalize the denominator if there is a radical. Okay? So let's look at a couple of problems. Let's look at this problem first. So example 1. We are going to simplify 9 divided by 7 plus radical 6. Okay? So for this problem, because you cannot have a radical in the denominator, and the denominator is a binomial, then what you're going to have to do is you're going to have to multiply the top and the bottom by the conjugate. The conjugate is just exactly like the denominator, but you're going to have a different sign in between it. So 7 plus radical 6, the conjugate would be 7 minus radical 6. Okay? So you're going to be multiplying the top and the bottom by that. Alright, so what is that going to be? Well, on top, you're going to have to distribute the 9 times everything. So 9 times 7 is 63. and then minus 9 radical 6. Okay, on the bottom, what ends up happening, because if you remember from that previous example, when you multiply a binomial times a binomial and you use FOIL, that outside and that inside canceled out. So we don't need to worry about that when you're multiplying by a conjugate. These will always cancel out. So you're just multiplying the first term, 7 times 7, which is 49. And then you're multiplying the last terms, the square root of 6 times the negative square root 6, which would be negative 6. Again, that would be negative square root of 36, which is 6. And if you just remember, those will always, the radical multiplied times itself just cancels out the radical. So now we just need to simplify it. So we have 63 minus 9 radical 6 divided by 49 minus 6 is 43. Okay? The only other way that we could simplify it further is if there was something that could get divided out of all 3 of these numbers on the outside. But because there's not, then this is my final answer. All right, let's look at another example. Okay, so this time we're going to have 5 divided by 8 minus radical 6. Okay, so again, we need to multiply by the conjugate. So I want you to pause this and work through it and see if you get the same answer as I do. Okay, so I got 40 plus 5 radical 6 divided by 58. So hopefully that's what you got too. Okay, next example, we have negative 3 square root 5 divided by square root of 7 minus 2. So again, to simplify it, we want to multiply by the conjugate. So on the bottom, it would be the square root of 7 plus 2, which means we've got to do that on the top as well. Okay. And let's see what that's going to give me. So we're going to distribute negative 3 radical 5 times radical 7. You're going to multiply the radicals together, so you're going to have negative 3 radical 35. Okay, and then negative 3 radical 5 times 2 gives you a negative 6 radical 5. And then in the denominator, radical 7 times radical 7 is 7. And then negative 2 times positive 2 is a negative 4. Okay, so let's go ahead and simplify this out. We can't really combine the top, so let's just write down what that is. Negative 3 radical 35 minus 6 radical 5, okay, divided by 3. Okay, now here's where it's going to be a little bit different. You can... all of these numbers that are on the outside here, the negative 3, the negative 6, and the 3, they're all divisible by 3. So what we're going to do is we're going to go ahead and factor out a 3 on the top. So bear with me. I'm going to factor out a 3, so that's going to give me a negative 1 radical 35, and then minus 2 radical 5. Okay, and then leave the 3 on the bottom. You always want to factor out the number first, and then you can cancel, okay? You don't want to try and cancel it before you factored it out, because you just end up making a careless mistake. So then my final answer would be negative radical 35 minus 2 radical 5. Okay, on this next example, I want you to try it on your own, and then when you come to class tomorrow, we'll see how many of you got this one right. Okay, last example. This is kind of a review from the night before. Our denominator is a cube root of x, so we need to multiply it times something that will get rid of that cubed root. Well, cube root gets rid of something that has, it's getting multiplied by itself 3 times. So we need to multiply by the cube root of x squared. That way it would be the cube root of x cubed, and it would go ahead and get rid of the radical. So we're going to have to multiply the top and the bottom by that. Okay, so on top I'm going to have to distribute it. So I'm going to end up with 2 times the cube root of x squared plus the cube root of x cubed, which would just be x. Okay, and then on the bottom, cube root of x times cube root of x squared is cube root of x cubed, which would just be x. Okay, now the only other way that I could simplify this is, number one, if I could take the cube root of x squared, which I can't. The other way would be, could I cancel out the x? Well, be very careful. You don't want to cancel out this x out of just this. You'd have to cancel it out of all 3 positions. And you can't. So since there is no, so I'm just going to write this down. If there is no GCF, then there is no reducing that you would do after this. Okay? So this right here is your final answer. Alright, hopefully that was explained well enough. Please come to class tomorrow, and please put any comments on anything that you did not understand so that I can go over questions on that tomorrow. Have a good evening.